All right, folks, it's Bass Action, back in action here. In this video, I am going to go through graphing secant and cosecant. I'm going to make reference to these graphs up here at the top. I want to make a note at the very beginning here that these are not currently graphs of secant or cosecant. These are our sine and our cosine graphs that we will use to understand secant and cosecant, since those are reciprocals. So let's get into identifying our transformations, then we'll get into what it would look like for secant and cosecant. So for starters, on our first problem here, notice that we want to ultimately graph secant, but what I want us to initially think about is I want us to think about this in terms of cosine. All right, now we're going to identify the transformations in the exact same way that we've done before. So we can first identify our dilations. Remember, the horizontal dilation is going to be found as the coefficient on the x. So we can identify that dilation. It is going to be a reciprocal, so the horizontal dilation is a factor of 3. Our vertical dilation, there is no vertical dilation, so there's a none there, because our coefficient is still a 1. That negative is going to tell us, though, that we are going to have a reflection. So we want to watch out for that. Now, in terms of our translations, our shifts, our horizontal shift is found inside this parenthesis, but right now they're all mixed together. So we can't find the horizontal shift until we factor out the 1/3. When I factor out the 1/3, this becomes x plus pi over 2. Now, this is going to be our horizontal shift, and we can recognize that now as a negative pi over 2. Our vertical shift is this 2 that's sitting out front, so it's going to be up 2. Now, at this point, since we're initially want to think about this in terms of cosine, now I want to go look at the graphs that I have up here at the top. What I want you to recognize is that this is our parent cosine graph, and this graph here is the graph of cosine with all these transformations. We can see that our point has been shifted back pi over 2. We can see that we have the reflection. Instead of going down, our curve is going to go up. We can see that our center line has also moved, and our center line is now right here at 2. That's going to be significant for us. So there's our vertical shift. So we can see all these transformations in this cosine graph. We're going to come back to this graph when we finish off our secant table in a moment. Now, I'm going to come back to these values here in a minute because they are more complicated for secant and cosecant. Let's go ahead and fill out our t-chart. Okay, our secant of 0 is 1. That's at an angle of 0. Our secant of pi over 2, this is going to be undefined. We haven't talked about what that's going to look like yet. Secant of pi is a negative 1. Secant of 3 pi over 2 is undefined again. And secant of 2 pi is 1. Now, just like we did before, we can find our transformed t-chart. Remember, we're following that DRT. So we're going to take our horizontal dilation, and then we'll subtract our pi over 2. On our y's, we're just going to add 2 to all of our y values. Let's fill in these y's real quick because they're easy. Remember, these two are undefined, so those can't shift at all, so these will stay undefined. Oops, not writing that very well. Then our y values, we just need to add 2, which makes this a 3 and a 1 and a 3. Now, let's take a look at the x's. Those are definitely going to be more complicated. We're going to take the x value, we'll multiply that by 3, so 3 times 0, then we'll subtract our pi over 2. That gets us to a negative pi over 2. Then we'll take still going to multiply by 3, that's now 3 times a pi over 2. Then we're going to subtract a pi over 2. That gives us a 3 pi over 2 minus a pi over 2. I'm going to leave this as a 2 pi over 2. The nice thing about this is now I can see that the increase from a negative pi over 2 to a 2 pi over 2 is a 3 pi over 2. So if I recognize that this is a plus 3 pi over 2 now, I don't have to continue with my math and my longer math, and I can just fill this in then as a 5 pi over 2, an 8 pi over 2, and an 11 pi over 2, just adding that 3 pi over 2 each time. That makes my table a whole lot faster for me. Now, how do all of these points connect with what we have up here on this graph? So what's going to happen, since secant is a reciprocal of this cosine graph, those undefineds that we see down below, those are where it's crossing this center line. Those will be our undefineds, and those are going to become asymptotes now. That's why they were undefined. Now, these portions of the cosine curve are going to flip. So if we look in our t-chart, we can still see these values. This is going to become a shape that looks like this. It will approach the asymptote. This is only going to give me half of it right here and the other half right here, again, approaching my asymptotes. What this is going to do, though, is it's going to dramatically change our domain and our range, okay? No longer will our domain or our range be between two numbers. Now it's going to exclude this entire amount. And then our domain can't be all real numbers anymore because we have these asymptotes. So when we go to write our period and our domain and our range, that's going to be impacted by these undefined values here. So first of all, our period, that's the same thing as before. Period is 2 pi over the omega, in this case is 2 pi, times the reciprocal of 1/3, which is 3, which is a period of 6 pi. We're going to use that in a minute. The domain, since we need to write this in a way that shows that we can have all of these values except for when we have these vertical asymptotes, what we're going to do is we're going to say x, oops, sorry, my app is being a little funny here. Let me go back. It'll catch up. There we go. We'll say x such that x is not equal to. Now, we're going to choose an asymptote. We can find these asymptotes in our t-chart here. So our asymptote, we see that we have an asymptote. The x value that asymptote happens here is at 2 pi over 2. I can write that as pi. So x such that x is not equal to pi. Let's write ourselves a note. This is an asymptote. And we're just getting that from our t-chart. Plus, now the asymptotes don't happen over the whole period. They're only half the period away. So this is going to be plus 3 pi k, because this is 1/2 of the period. I know this is kind of messy, but we can do this. Now, in terms of our y values for our range, we've got this 3 and a 1, but instead of being between these two values, we're going to be outside of it. So our range is going to be -infinity all the way to a 1. We'll be inclusive at that 1. Then we'll start over again at the 3 and continue on. And that matches what we have on our graph up above. Let's take a look at a cosecant graph. We're going to do the exact same thing. Let's find all of our transformations. Remember, we're going to need to factor that too. Okay, so our horizontal dilation is now going to be a factor of 1/2 because it's this reciprocal. Our horizontal shift is going to be a positive pi over 2 this time. Our vertical dilation, we do have a vertical dilation this time. It is going to be a factor of 5. Again, we're going to have a reflection. And then our vertical shift is the 3, and we're going to go up 3. Now when we complete the t-chart here for our cosecant, we'll have cosecant is undefined at 0. So now we're going to start with an asymptote. Then we're going to have our 1, and then we're going to have an undefined again. Then we'll have our -1, and then we'll have an undefined again. Remember, we're just evaluating cosecant at each of these values. Just like we did before, our y's are going to be pretty straightforward to do. We do need to follow our DRT. So that means that we're going to take our -5 times our y value, and then we're going to add our 3. That means that this will still say undefined. We won't have to do very many. Let's go ahead and fill in where these asymptotes are going to happen. Now, that means that we really only need to calculate these two values. So we have a 1 times a -5. I can even write it out. And then we're going to add our 3. This is going to get us to a -2. On our -1, we'll have our -5 times our -1 and add our 3. That's going to get us at 8. These two values should give us our range. So we're going to write them, and then we'll verify them with the graphs up above in just a moment. So we'll say -infinity to -2. That's inclusive. We'll start again at 8 and go to +infinity. Let's go ahead and look at our x values. For the x values, we're going to use our dilation. So we'll have our 1/2 times our angle of 0. And then we're going to add the pi/2, which gets us to pi/2. On our next one, we're going to have 1/2 times pi/2 plus pi/2. Now we need common denominators. So that's going to give us a pi/4 plus a 2 pi/4 gets us to a 3 pi/4. Let's rewrite our pi/2 as 2 pi/4. This is going to make our pattern easier. 2 pi/4 to 3 pi/4, we just need to add 1 pi/4 each time. So this gets us to 4 pi/4, 5 pi/4, and 6 pi/4. That tells us that our asymptote is happening at pi/2 or 2 pi/4. Our period is 2 pi over omega or 2 pi over 2. So the period is pi. So the domain x such that x is not equal to, pick your asymptote, it's pi/2, plus, now we need the period divided by 2. That's a lot of details to keep track of. And then we'll have our k. We'll talk more about these in class, but remember, this is 1/2 the period, and this one is an asymptote. That's why we're going to definitely make these little t-charts. Now, let's take a look at how this connects to what we have up above here. If we come up here and we look at this graph, this was the original parent graph for sine. This is the transformed sine graph. We can see that our center line has moved. We can see the vertical stretch, and we can see the reflection. To turn this into a cosecant graph, everywhere that it touched that center line, these became asymptotes, and these match what we have in the chart down below. Then these parts turn into, they almost look like little U's. I don't really want to say they're parabolas because they approach an asymptote, but they kind of have that feel. So this is what our cosecant graph is going to look like. We're going to do more with class, but definitely make some notes about what parts of this seemed confusing to you so we can make sure we get those questions answered in class.